All right, welcome back. So, this is lecture 6 in this course, Mathematical Tools for Cognitive Sciences. The topic of this lecture is inverse functions. Okay. So, in the previous lecture, I introduced you to functions. So, what is a function and some important properties of the functions that we need to figure out, right? So, what is a function? So, function is a process that takes some input and gives a corresponding output, and exactly a single value as output corresponding to an input value, right? And how this output and input value corresponds, that depends on the structure of this process, the structure of the function, right? So the function tells you the relationship between the output and the input, right? So you can think of it as some operation you are doing on input values to get some output value. Okay. So one of the example of a function is a straight line, right? So what happens in a straight line? You can think of a straight line as a linear function of x, right? So it takes some value of x, right, and multiplies that value with some slope and adds an intercept to it, and you get as a result a value of y. Okay. So y here is the output of the function and x is the input. Okay. So in simple terms, function is a process that takes some input and yields exactly a single value as output. Okay. Now we discussed two important properties for a functions which are critical for understanding how the function behaves and how to draw the graph of the function. One was the domain of the function and another was the codomain of the function, right? What is the domain of a function? Well, domain is the range of, or you can say the set of all the values that the input variable can take. Okay. So it's a range of all the values that the input variable can take. Okay. So what possible values the input variable can take, it's called the domain of the function. So it is not necessary that the input variable x can take all real values, and we saw examples that sometimes it is not possible that the input variable can take all real values. Okay. So sometimes it takes all real values except let's say a couple of values. That can happen. So for example, when you have the x term in the denominator, then the denominator cannot be equal to 0, otherwise the term would be undefined, right? Similarly, we can also figure out what all possible values the function can take. Okay. Basically all possible values that the output can take. What is the set of all possible output values, right? And that is called the codomain of the function. It's also called the range of the function, but we will use the term codomain of the function. Okay. So given a function, we should be able to figure out its domain and codomain. And once you figure out domain and codomain, it helps you to draw the graph of a function. So we took some examples where we practiced how to find domain and codomain of a function. We will take some more examples in this week. So we will do a few more exercises on finding domain and codomain of a function. Okay. But before that, I'm going to introduce you an important concept which is called inverse of a function, or you can call it inverse functions. Okay. So what is an inverse function? So let's say you are given a function of this form, f of x, okay, where x is the input variable. Let's say the output variable is y. So let's say this function f maps some input variable x to y. Okay. So let's say y is equals to f of x. This is how you can write. So y is the outcome variable, x is some input variable, and f is the function, basically the operations you are doing on x. Now, what you can do actually is this. Think of f as a process. So f is a process that is being applied on this input variable x. So you are applying some process, okay, on this input variable x to yield exactly single value y. Okay. But can you think of a reverse process that takes y as the input, okay, and gives x as the output. Now this is a reverse process. Okay, this is not exactly the same process as f. This is the reverse process of f, right? So there is some process f. What this process does, it takes x as input and gives y as output. Now think of another process which takes y as input and gives you x as output. Okay, so this is the reverse process of this process f, right? We call this the inverse function. Okay, the inverse function. This is an inverse function of f. So f, I'm indicating it using f to the power minus, right? So I'm indicating f exponent minus, okay, to denote that it's an inverse function of f. Okay, so what is an inverse function of f? A function that takes y as input and gives you x as output. So basically it does the mapping but in the opposite direction. So it's a reverse process that takes y as input and gives you x as output. So let us see how it works in practice. Okay, so let us take some example. Let us take some simple function and let us try to derive what would be its inverse function. Okay, so let us take a simple function y, or let me write a function form, f of x equals to 2x plus 3. Now this is a simple function. Let us try to derive the inverse of this function. Okay, what would be the reverse process that would take the values of this function as output and would give values of x as input. So right now this function does the mapping in this way. You take some values of x, let's say 0, 1, 2. It gives you some output. Let us call the output y. Okay, so let me call the output y. Okay, so y. So corresponding to x, you get corresponding to 0 you get 3, corresponding to 1 you get 5, corresponding to 2 you get 7, right? So this is how it is doing the mapping. But we want a so this is function f, but we want a function which does the mapping in this way, that it takes values like 3, 5, 7 as x and gives you output in this way, that you get 0, 1 and 2. Okay, so it takes 3 as input and gives you 0 as output. Okay, that's the idea. This would be the reverse process of f, or reverse function of f. Okay, so let us see how to derive. We are going to see step by step method of how to derive the inverse of function. So let's say the function, we take the same function, is 2x plus 3. Function is 2x plus 3. How to derive inverse of the function? So step 1 is this, that you represent f of x using some outcome variable. Okay, so we used to do this earlier as well. We used to consider y is equals to f of x. So y is the outcome variable. So we can replace f of x by y. Okay, so that's our step 1. Replace f of x by a variable y. Now this y is an outcome variable for this particular function. So replace f of x by y. Okay, so we can rewrite this equation as y equals to 2x plus 3. So we written this in this form. Okay, so we just replaced f of x by y. Now step 2, write, or let's say solve this function, solve this equation. This is an equation now, but it has 2 variables, remember. Solve this equation for x. Okay, we are not going to exactly solve this equation because x wouldn't have a value, because it's not a equation of single variable. It has contains 2 variable. But what we want is that x comes on the left hand side and everything goes on the right hand side. So we want some expression of this form, x equals to something and this term can contain y. Okay, so this is how we want to solve this equation. So we want to solve this equation for x. We want x alone on the left hand side and everything else on the right hand side. So we can do that, right? Given this equation, we can simplify this equation such that we take x alone on the left hand side. So we can write 2x equals to y minus 3. We take 3 on this side, so 2x becomes equals to y minus 3 and x would become equal to y minus 3 by 2. So, x becomes y minus 3 by 2. Okay. So, this is what we have got so far. So, we have got x as a function of y. So, what we have at this point is something like the input variable as a function of outcome variable, right. So, we have already achieved the form of our inverse process, the reverse process that we are going to apply. So, this is the process that is applied to the variable y to yield values of x, right. But we need to write it in a different form. So, we just need to change the form of this. How do we do that? Now, replace y by x. So, replace this outcome the variable that was the outcome variable before, replace it by x and replace x by f inverse x. Okay. So, we are going to call this the inverse function, because this is the outcome of the inverse function and this is the input variable of the inverse function. So, we are going to write it in the form of an inverse function. We are going to write it in the form of function, but this is a different function. This is an inverse function. Okay. So, we are going to write it in the form of a function such that y is the input of that function and x is the output. So, if x is output, we can replace x by function, right, f inverse x, and we can replace y by x because that is the input. Okay. If you want, you can replace it by some other variable as well, right. So, if you find this confusing, if you think that replacing y by x is confusing, we are replacing some output by input, that is not what we are doing here actually. We are just saying that now x is a function of y, okay, but actually we want to write it as a function of x, not as a function of y. That is why we just replaced y by x, and here on the left hand side we write f inverse x because that is the function we are looking for. But if you want, it is totally fine to replace it with some other variable, let us say h. Okay. So, I just replaced x by f inverse h and I replaced y by h. This is totally fine because this is exactly what we are looking for. This is the inverse function of the function that we saw here, f of x equals to 2x plus 3. But just that we want this, we want the variable to be in the same form. So, that is why what we typically do is we write f inverse x equals to x minus 3 by 2. Now, this is the inverse function of f of x, and what was that function? 2x plus 3. Okay. So, f inverse x equals to x minus 3 by 2 is the inverse function of f of x equals to 2x plus 3, right. Not that we will use this notation and we will call it f inverse, right. So, I am just putting this exponent negative with f. So, we will call it f inverse, right. So, f inverse of x equals to x minus 3 by 2. Okay. So, this is how we find the inverse of a function. Now, let us check whether this function is doing something like this. That is what we wanted, right. So, it takes some values of x, and what values? We defined some values there 3, 5, 7, and it should give 0, 1, 2. It should take values, let us say 3, 5, 7. This is just for verification, and it should gives us some output. What should be the output? 0, 1, 2, right. Okay. So, this should be mapped by this inverse function f inverse. Okay. So, let us see if you plug in. So, this is our function now, okay, f inverse x is equals to x minus 3 by 2. So, if you plug in 3, yes, then the value of the output will be 0. If you plug in 5, then the output would be 1. If you plug in 7, then the output would be 2. Yes, it does the mapping. So, this is indeed the inverse function of f of x. Okay. So, this is how you can find the inverse of a function. Now, let us do some practice. Let us take some more interesting examples. I am going to call these in-class exercises because I will write the problem here and you should try to practice it before seeing the solution. So practice it yourself. You can pause the video, practice, and then you can see the solution, right? So first, find the inverse function of this particular function f of x equals to 1 minus x square, or let us take slightly different. F of x equals to 1 divided by 1 minus x. Okay, you need to find the inverse of this function f of x equals to 1 divided by 1 minus x. Okay, where of course when I define a function, I can give some conditions where x is not equal to 1, right? X can't be equal to 1 here. That's the domain. Okay, so let us find the inverse of this function. If you have done this problem earlier, you know the domain and codomain of this function, right? What would be domain? So x can take all real values except x equals to 1, and what values y can take? So let's say 1 divided by 1 minus y. So what would be codomain? 1 minus x equals to 1 by y, x equals to 1 minus 1 by y, right? Y minus 1 by y. So actually y cannot take 0, right? Except that y can take all real values, right? So that is the domain and codomain, right? So let me write the domain and codomain as well, because something interesting is going to happen with domain and codomain when you find the inverse function. So domain is this, that x can take any real value except that x can't be equal to 1, right? And codomain is that y can take any real value except y is not equal to 0. Okay. So this is the domain and codomain. Now let us try to find the inverse of this function. So we will follow those 3 steps of how to find the inverse of a function. Let me write the function clearly here, 1 divided by 1 minus x. Okay. Step 1. In the first step, replace f of x by y. Replace it by some outcome variable. One, you can use, rather than y, you can use something else as well. Let's say z or something, right? That doesn't matter. It's just a variable. So step 1, y equals to 1 minus x. Now in step 2, we solve this for x such that the x comes on the left hand side. Okay, so 1 minus x equals to 1 by y. X would be equal to 1 minus 1 by y. Okay, so we have solved this for x. What would be step 3? So in step 3, we now change the form, right? So we replace y by x and we replace x by f inverse x. Okay, so replace x by f inverse x and replace y by x. Okay, so f inverse x would be 1 minus 1 by x. So this is the inverse function of the function f of x equals to 1 divided by 1 minus x. Okay, so this is our inverse function. Now if you want, you can draw the graph of the function and its inverse function. But before that, let us find the domain and codomain of this function as well. Okay, what would be the domain and codomain of this function? Now what possible values x can take? Well, x can take all real values except x here can't be equal to 0, because if x is equal to 0, then this term would be not defined. And what values the function can take? What would be the codomain? Okay, so the codomain of this function f inverse x would be such that well, we can find it out using the same method. So let's replace f inverse x by y. Y equals to 1 minus 1 by x. So what possible values this output can take, right? That's what we want to figure out. So it would be 1 by x equals to 1 minus y, and x equals to 1 divided by 1 minus y. That means 1 minus y cannot be equal to 0, otherwise it would be undefined. So y cannot be equal to 1. So, the codomain is such that the function cannot take this value y equals to 1 and it can take all other real values, right. What does this imply? See, an interesting thing happened here. For our function, original function 1 divided by 1 minus x, domain was such that x cannot take 1, x cannot be equal to 1 and y cannot be equal to 0. Now, in our inverse function, the opposite thing happens, x cannot be equal to 0 and y cannot be equal to 1. What does this mean? For an inverse function, the domain of the function becomes the codomain and the codomain becomes the domain. Okay. So, in our function, the domain was x can't be equal to 1, x cannot take the value 1. This becomes the codomain. Now, the output variable cannot take the value 1. And whatever was the codomain earlier, that the output cannot be equal to 0, that becomes the domain, that x cannot be equal to 0. And that makes total sense, because exactly what has happened in this process, that there was something, an input variable x and y, and we had some function that maps x to y. Now we are trying to figure out an inverse function that maps in this direction, that maps y to x, right. So, inverse function that basically takes y as input and gives you x as output, right. So, it is a reverse process. So, that means whatever was the outcome variable earlier becomes the input now, and whatever was the input variable earlier becomes the output now. So, the domain and codomain will switch, right. So, that is what happens. Now, let us draw the graph of this function, both our original function and the inverse function. The original function was 1 divided by 1 minus x, inverse function was 1 minus 1 by x. Okay. You can also rewrite it as x minus 1 by x, right. So, let us draw the domain and codomain, the graph of these two functions. Let us first draw the graph of 1 divided by 1 minus x. We drew this graph earlier. So, what happened in this graph was that x cannot take the value 1. Okay. So, whenever some variable is undefined for some value, we can always draw a line there. So, if x cannot take the value 1, we can draw a dotted line here, because what would happen is that the graph is probably going to be asymptote along this line, right. So, x cannot take the value 1. If you put x equals to 0, value of y is 1. If x is 1 by 2, then the value of y is 2. And if x is very close to 1 but less than 1, let us say 0.99, 1 minus 0.99, 0.01. So, it becomes a very large positive value. So, the graph grows like this, right here, and because it cannot take y equals to 0, this is what we drew earlier as well. So, the graph grows like this in this direction. Okay. Similar thing would happen here. The graph grows something like this. Now, this is not a symmetric graph along the y-axis, by the way. So, this is not a mirror image along the y-axis. You can say this is a mirror image along this line, okay, but not along the y-axis. Okay. That kind of thing, that symmetric graphs arise only when you have x square term in your left hand side. Anyway, so this is the graph of f of x equals to 1 divided by 1 minus x. Let us draw the graph of 1 minus 1 by x. Okay, I will draw this graph using a different ink, using red ink. 1 divided by 1 minus x, or you can also take this x minus 1 divided by x, right. So, what would be the value at x equals to 0? So, when x is 0, so it won't be defined at x equals to 0. But what if x is 1? So, when x is 1, the graph would be defined and it would have a value 0. Okay, so at x equals to 1, this graph would be here. And what would be the value at but this graph would not be defined here. So let me just draw a dotted line at y equals to 1. Okay, so it is defined here. But as, let's say, value of x grows in the positive direction, let's say x becomes 100, then this term would become very small, right? So 1 minus 100 would be, now it would be, you are trying to reduce something very small from 1. So it would be slightly less than 1 and would never reach 1 as you keep increasing x in the positive direction. So this is how the graph look like here. Okay. Now what if you decrease x less than 1? Let's say you take x closer to 0, let's say 0.001. If you do that, then it would be 1 divided by 0.001, that is 1000. So minus 1000, 1 minus 1000, minus 999. So it is going to become large negative value. So the graph would go like this. Okay. And now let us think about the other direction. So what if x is negative? So let's say x is slightly greater than 0, slightly less than 0, minus 0.01. So it would become positive 1 plus 1 by 0.01. So 1 plus 100. So it is going to be a large positive value actually, okay, when x is close to 0, right, but negative. And if x is large negative, let's say minus 1000, then it would be very close to 1. So the graph should look something like this. If x is close to 0 versus when x is large negative value. Okay. So now this is the graph of f inverse x is equals to 1 divided by 1 minus 1 divided by x. Okay. So this is how these graphs look like. Now there is a question for you. Do you see any sort of relationship between these two graphs, between the graph of the original function and its inverse function? Do you see any relationship or any symmetry or any sort of like, can you predict the inverse function graph when you are given the graph of a function? That's a question for you. You can take a look at this graph, you can try it yourself and try to figure it out. We will resolve this in the next lecture, okay, when we discuss the graph of functions and their inverse functions. We will take some more examples and we will work out their inverse functions and we'll draw their graphs. Okay. All right. I will stop here. Thank you very much.